Everyone, so today we are going to talk about a new topic related to civil and environmental engineering field. Okay, so we are going to talk about a reinforced concrete project design, analysis and design for this project. What we are going to talk about in this lecture, we are going to talk about the architectural description, the design criteria shoring system today. And for the latest for the last two of structural analysis and foundation, we are going to talk about these two in the part two of this lecture. We are going just to introduce today our project, and we talk about the design criteria and choice system only. So this lecture will cover these three topics. So what is our project? So our project is, in reality, we have a project which exists in real life. We have a project called the Verdun Garden. This project is located in Beirut, Verdun. It consists of four blocks. We have a block B and a block C. These two are reinforced concrete building, and these two A and A prime are shopping centers, which mainly are designed as or executed as a steel structure system. Okay, we have just I need to shed light on this one. We have here a part. We have here what we have here is adjacent road, and here we have this section faced what an existing building, and here we have a section also only faced what roads. Okay, so this explanation is related to the choring system of this project. Now, as we can see that the shape of our project is a curve, just to give the person or the individual a large range of view for the whole city. Okay, so we are going to talk about the design criteria for this project. What is our design criteria? So we have a code of practice and standards. We are going to use the latest ACI for determination of load combinations, the design and detailing of various concrete elements also. You are not going to use UBC because UBC, I believe UBC 97 is not used anymore. Actually, we are going to use the latest version of ACSE 05 for wind calculation and for earthquake forces. Okay, so the materials we can just stick to this material element specification related to concrete F prime C and to steel Fy. We can change these or these or these. It's not a problem. We are going to use 20, 35 and 50 MPa for plane, horizontal and vertical element. And we have two categories of steel, 280 and 420 MPa for mild and high tensile steel. The loads, these criteria for loads, the lateral loads, wind and earthquake, usually related to the location of the project. As you know, the location of the project is Lebanon, so we are going to check using ACE for the specification for these two load related to Lebanon region. If we cannot find anything related to this location, we can just use LibNor or the specification mentioned in LibNor. LibNor usually is the design and analysis. The code practice usually is called LibNor. The code practice for Lebanon, when we are going to use code practice for building, where we are going to use the analysis and design for lateral forces. And for gravity loads and live load, we can just use these two suggestion. Okay, now we are going to talk about the shoring system. The shoring system is done using Plaxis software. It's an old version here in this presentation of Plaxis was used in this project. We are going to also to renew this design, this analysis using the latest version of Plaxis, the latest version of hand calculation also, because we are going to check the result of Plaxis with the result of our hand calculation to check if these two matches or not. We have in our project we have two sections for design. We have section with adjacent building facing section with adjacent road, and we have a section with adjacent road. So what we are talking about here is what we have a section facing a road, adjacent road, and we have a section faced adjacent building and adjacent road. Okay, so what we are going to talk about in the shoring system, we are going to talk now about the section with adjacent building. So we are going to design the shoring system for this section. Usually the section with adjacent building will take more reinforcement related to shoring than adjacent road, because we have here an adjacent building 15-story which is much larger than the adjacent road loads. Okay, here we are going to use diaphragm wall with anchors and lateral bracing. So we are going to do step 1 of excavation, which is we are going to use the step 1 for execution. Sorry, we are going to install the diaphragm wall in order to excavate the first layer. Then we are going to install the first anchor, left side and right side. We have left side and right side. The left side will be much larger or we are going to have much reinforcement on the left side more than the right side, because we have an adjacent building as we have seen. Okay, we have a 4-strand at 2 meter spacing with jacking force. We have a jacking force of 15 ton per strand, and the right side is at 3 meter with 9 ton. Okay, we are going to excavate the second layer. That we are going to add another reinforcement, another four strands at 2 meter with jacking force of 15 ton on the left side. Sorry. Okay, then the excavate on this third layer. Then we are going to use a lateral bracing now. The black one is a lateral beam with 4 times 30. Then we are going to go deeper. We are going to use another bracing, but larger than the first one, which is now will become 50 times 45 at spacing of 5 meter. Now we are going to excavate the final layer. Now we are going to check using Plaxis the total displacement, which is in millimeter or meter. We have the largest one is 34 meter, 34 sorry times 10 negative 3 meter, which is 34 millimeter, which is reasonable at this location. Okay, so this is the point displacement. Okay, and also we are going to talk about this in detail when we are going to do the analysis using Plaxis. We have the left wall, anchor and bracing. We have the internal forces of these three shoring element. Okay, now what we have here is a hand calculation. We are going to check the anchor capacity, the bonded length required, wall thickness, flexure shear and thickness used, bracing beam, waller beam, steel beam, embedded concrete beam. We are going to check all of these using hand calculation with respect to to our Plaxis analysis. Okay, and this is a plan view for our shoring system. We have here a lateral bracing. Okay, and here we have the anchors. Okay, and what we have here also the anchors. Okay, so if we are going to see, if we want to see this plan view, we can just go to this section. Let's say plan view. If we put here plan view, okay, okay, I believe we don't have a plan view for this one, but we can use AutoCAD to see it, no problem. But this is actually the much more accurate, the much more accurate than these, يعني, these picture. So what we are seeing here is this side, which is what, which is usually this side. Okay, this one, like this. Okay, okay. Now we have the section with adjacent road. This one is also designed, used strand and anchors and wall diaphragm. Now, for structural analysis, we are going not to continue structural analysis. We are going to stop here today. I'm waiting for your feedback. If you have any comment, any question, any suggestions, please feel free to leave a comment. And don't forget to subscribe in my channel. Bye bye.